Hey, thanks, YC. And also a huge shout out to the entire ECE support community. Without your help, we couldn't have met over Zoom for throughout the pandemic. Also, a big shout out to Sean. I hope he's okay and he's feeling better. But we've had these ideas. Yeah, I see Sean, but I don't see. Okay, hey Sean, you're here. Okay, hi Sean. And we've been talking about curriculum before pandemic, during pandemic, and now almost post-pandemic. And then like we always do, we try to label everything with a subtopic. And so one of the things that came about during discussion is the threaded and concentration-focused curriculum in ECE. And the words have been around for a while. The discussions have been made during conferences. But what I think is going to be discussed in next few minutes is about how do we integrate the content so that students feel more engaged, and then how do we make them confident when they graduate? And that is the core of the discussion. We have experts, we have alums, we have entrepreneurs, we have industry experts, and we have faculty. So I hope you enjoy the panel discussions, and a huge thanks to the panelists and the moderator, Ayesha, for organizing the next one. And Ayesha, I'm going to pass it over to you now. Thanks so much, and take it from here. Thanks.
Well, hello, everybody, and good morning. I'm excited to be here. And, I think, Sid, I'm really appreciative of this opportunity that you called me last week and said, hey, can you do this? But very excited to be here. I know you're in India. Enjoy your trip, but we have a great panel ahead of us, and I expect a lot of questions from academia and industry. I'm Ayesha Mihir, in case you don't know me, Texas Instruments. We're going to kick off our first panel, which is on the threaded and concentration-focused curriculum. Now, we have a group of panelists that are really diverse and honestly very distinguished. And I think this is going to be also a good learning for me, as I've spent the last 6 years of my career professing industry readiness in students. And being a graduate of ECE, I know personally well how unclear students are, especially during the undergraduate studies. Okay, I was a biomedical undergrad and I jumped into ECE for my master's. So I know that there are always these questions of what is the direction that I need to take or we need to take. So really an important discussions. And as you know, students have lots of options. ECE is a very broad, wide field. And, students want to know whether they should continue with higher education or get their first jobs when they graduate, and what industry should they be part of. Also questions like, does following passion really lead to success? Can one change careers in industry within ECE? And even questions like, is startup an option for me? Do I need to get a branded industry title on my resume, even if the job is not interesting to me? Well, freshmen need to know all of this upfront these days. So this is indeed a very daunting task. And unless they have guidance or inspiration, either from their parents or faculty, they'll go about their math, physics, and core courses, even trying the path of least resistance as they cruise their journey in college. Would threaded and focused curriculum offer a pathway to the students early on that could help? Today, we may not get all the answers, but hopefully we can get some insight and start the dialogue. So with that, today on our panel, we have three distinguished speakers. I'd like to introduce Dr. William Kaiser, or Bill. He's a professor at UCLA. Then we have Mihir Shah, who is an entrepreneur with some remarkable success of doing startups in the Bay Area. And then finally, YC Wang, who is also director of global academic program at DigiKey. And indeed, he has a broad view on industry and roles in ECE and what is needed. I'll moderate this panel, but request you to send your questions via chat, and happy to get this started with Bill.
Thank you so much. I really appreciate this opportunity. Ayesha, thank you for your inspiration. Sid, your inspiration. Mihir, our great discussions in YC. Always have appreciated this. I was introduced to ECE and way back in '96, where I served as department chair at UCLA in electrical engineering from '96 through 2000. And I've been involved in the development of design courses in all the 27 years at UCLA. In fact, my very first department meeting, only about 1 week after I had arrived, I proposed a design course, which I then created. So over the years, this has been a big focus. But my primary passion right now is about the threaded and focused curriculum, and in particular, its early introduction. So if we could share the slide, that first slide, that would be outstanding. Or I could share at my end too, it's up to you.
Yeah, I can share it. I saw it being shared earlier.
So anything I'm engaged in, literally, this is my passion and just a primary driver. So the slide might be somewhat concatenated here a little bit, but let me get started. Oh, thank you very much. Again, really appreciate this. So first of all, research on engineering education, formal research, has definitely shown that there is, as we all know, an unfortunately high dropout rate after the first 2 years. One reason why that is because students necessarily must build a background in mathematics, physics, chemistry. And this might go on for 2 years before they have a chance to invent and innovate as driven by what brought them to that electrical engineering program. So we focus on early introduction to threaded principles, literally in the very first quarter, first semester of their program. So this is their first class. So it provides early motivation, inspiration to students, and provides them with a resilience. So it's a challenging course, but really rich in inspiration. So students overcome obstacles, and ultimately our objective is to instill self-confidence, to allow students to know that they are going to encounter challenges, but that there's a reward when there's a success. It also inspires engineers to select a discipline of concentration within electrical and computer engineering. So what are the disciplines in the course? Well, computer engineering, embedded, sensing, sensor principles, digital signal processing, algorithms, machine learning. How do we do this for freshmen? Well, we've learned over the years, we have a curriculum. A great deal of this is online and available for any instructor. And for any instructor that needs additional lecture materials, we provide that. So there's 2 courses. Some students take both. One is focused on Internet of Things. It uses the kit at upper right, the ST microelectronics sensor tile, which provides a student with access to everything: sensing, signal processing, embedded computing, wireless communication. And then a second, at lower right, another kit is an inverted pendulum, very precise system with digital actuator, digital sensors. Now, this is scalable. Students actually purchase these kits at a cost less than a textbook. So it's remote capable. We've offered this remotely, winter, spring, summer, fall. And it's also scalable for institutions that might not have a laboratory or laboratory space. What are the outcomes? These courses have the highest overall scores of anything we've ever measured. One critical formal evaluation is student interest in a discipline and how that's grown during the course. That's measured by our course assessment, and that always goes up. It's dramatic, and we are thrilled with that. That's a success. I'll close, but I wanted to offer 2 examples of independent student development that was inspired by their freshman threaded curriculum experience. So one was embedded machine learning, a development by a student from this curriculum independently. It's an immense breakthrough, a computationally efficient and memory efficient machine learning library with both real-time training and real-time execution on a microcontroller. It now operates on the ST sensor tile system, and it's tremendous. And we use this now in our course. It's a great vehicle. Another is probably anyone in control systems knows that digital actuators have always been afflicted by rate limits, similar to the rate limit of analog control for an operational amplifier. One of our students developed an acceleration drive system that's never been published before, referred to before. It offers linearity for these rate limited actuators. It's precise. And so these are both breakthroughs that independently were developed. I could go on and talk all day. I better stop. But in any case, we're thrilled and we really want to help with this. Thank you.
Thanks, Bill. So the next is Mihir Shah.
Hey guys. So yeah, this use it as you'd like. For me, this is I've worked at or gotten offers at over the last, I guess, 7 years at Tesla, SpaceX, Apple, and Axon are the main companies, and these are all places that are reasonably competitive to get jobs at. Especially Tesla and SpaceX are pretty aggressive. I mean, it was like 3 phone interview, 2 technical interviews, and then I walked in, and then it's a 5 to 6 hour day where you do a group presentation over a project that you've really had your hands dirty in. Usually it's walking them through a schematic, and then they'll usually pull out random schematics, plop them on the table and say, okay, walk me through this schematic you've never seen before from some body control board or for some safety airbag control module, whatever. And so they'll pull these things out and say, okay, you've never seen this. You don't have all the data, the details. It doesn't matter. We only have 30 minutes. Here's a pen. Walk me through like the power electronics or the DC-DC part or whatever. And that level of intuition is something that is oftentimes missing. And also this list, in many ways, it is kind of exhaustive of things that if every student, I mean, you just Googled all the words that I put and clicked a few of those links, especially the student manual for the audio electronics. I'm fairly confident that if they're able to do that and it's not like too much of a head scratcher, you'd probably get any EE job right out of undergrad, really regardless of the institution that you went to. This is pretty much what you need to do. Everything else, not really relevant. Nobody asks you it. No one has the time. Pretty much if you have your hands dirty and you get how pieces go together, you don't need to dive crazy deep. This is plenty. And just like Bill said, you don't really get to this until the 3rd or 4th year. And so if at the highest level, well, one, I wish there was a class on that just went over a new schematic each week. I think that would just be really interesting, and no one's really done it, but it is one thing that's consistent amongst every like competitive interview that I've been a part of is Apple did the exact same thing. They screen shared a schematic, and this was before the pandemic. And we kind of just walked through it like, okay, why do you think I did this? What's the purpose of these TVS diodes? Like things that you don't obviously learn in school or like part of basic ideal circuits, but more in application, you're copy pasting from other schematics, you're plopping them in yours. Most basic circuit blocks have already been designed by engineers in years past at a company. And oftentimes most schematics are just a mashup of other schematics. So that way you can reuse components that you have in stock that you're buying in bulk for the company or whatever. And so being able to think like that, not always trying to reinvent the wheel, being practical and being fast those are things that I think are not really taught in the EE curriculum in most institutions, but certainly can be. And they're pieced together more spread out over the course of years. When I think if you had 1 year, like a second or third year, probably a third year, by the end of that time, most people should have some familiarity with everything on this list, then they're good to go. But yeah, schematic reading, that would probably solve most of the issues, like pick a random schematic and have people walk through it, show how current actually flows through these different circuits and what you're trying to achieve. That was something that they really did for me when I was at Taser. We walked through, like, the first 2 weeks they're onboarding me as an EE on the new Taser systems and all the weapons. And this is new circuitry that I hadn't dealt with, like taking an 8-volt battery to 50,000 volts differential and things like that over a small size. How do you actually do that? And so a lot of the EEs, they just give me a schematic and say, okay, follow along. I got 30 minutes. And then they'd walk through, here's why we did this, here's why we did this, here's how you can expect to do this. And a lot of stuff was new for me, but I got it pretty quickly. So totally can be doing this stuff at the undergrad level. And then obviously I put a plug for my newsletter, another startup, just kind of related, a big opportunity, I think, in this space. So something I'm trying to take advantage of. But yeah, my last startup, we got acquired by Cadence Design Systems, large public company in the space. You guys probably teach OrCAD and Allegro. I was on the OrCAD team for the last year, and then startup bug bit again. So I left, and now I'm doing the next one. But yeah, if you do this list, I think anybody can get a job as an EE at literally any company, from Tesla all the way to some random controls company in the Midwest or whatever. So not that there's anything wrong with that, but it is different.
So thanks, Mihir. I think I like the idea of making engineering fun, as Kevin mentioned. So all these tools, all these insights, I actually totally agree with you, coming from the same areas you have, that these are critical. So our next panelist is YC. Just a minute.
Thank you very much, Aisha. Yes, I can start on this slide, but I'll tell you when to transition to the one right before that. So
Okay.
This is actually a little blast from the past. I built this for ECE back in 2015. I've been involved with ECE for a while. This was from one of my previous employers. And so so the topic of career paths is near and dear to my heart, because I feel that this will strongly direct it will strongly influence the direction universities in a particular geographical region build their curriculum and coursework to best support the industry in the area. So Aisha, could you move to a slide right before this? Okay, perfect. So right before the summit, out of curiosity, we did a very thorough survey of jobs in the San Diego area. We picked San Diego just completely randomly. We could have picked Indianapolis, we could have picked Philadelphia, or anywhere else. But I feel that San Diego, has a good balance of defense and also commercial jobs. So we did a very quick survey of the San Diego area, and basically did this through Google. So it's it's readily publicly available information, and the filter was basically for entry-level jobs with 3 or fewer years of experience. And the results were both surprising and unsurprising at the same time. I feel that universities should come to this awareness of what the local area offers. And I think Professor Kaiser, on one of the planning calls for this summit, he's obviously done his homework, and a lot of the hardware that he's built was built based on industry feedback and feedback from the students who have landed jobs in the industry. So anyway, back to this list here. You know, what I found surprising, and you know, is that employers are looking for students with the ability to program, or an understanding of a high-level programming language. And Python is becoming more and more popular nowadays, although C and C++ are, you know, still very high on the list. This comes from the fact that programming languages are becoming, you know, the tools for manipulating hardware. And I think a lot of ECE departments have also seen the conundrum of, well, I have a lot of students who are becoming more interested in software than hardware. Well, that may not necessarily be a bad thing, because you need things to drive the hardware with. And so it's definitely in every job listing I've seen, be it for, you know, someone who does PC board design, or someone who works with embedded microcontrollers. Also very high on the list are FPGA skills, particularly from the two predominant FPGA companies in the industry right now, and also Verilog and VHDL. A lot of people have you know, brought up to me that, hey, Verilog and VHDL are increasingly obsolete. Nowadays, people can use Python, Jupyter Notebook to get FPGA designs going, specifically for machine learning or IoT. Well, that you know, I think to some extent employers are still looking for a granular level, you know, down to the FPGA architecture level of manipulating things. So I feel that a lot of the keywords in this list actually matches what Mihir has on his slide previously very, very well. And so and you know what, Sid, I think there is a common theme here of building students up to a certain level of competency and willingness to learn, and then exposing them to all the possible electrical engineering topics. And that's the whole point of threaded curriculum. So I think this would be a great panel discussion here, and I'm all primed and ready for it. Thank you, Asia.
Thanks, YC. Do you want to cover this one too?
Oh, no, that's fine. I'll bring it up later. Thank you.
So I think we had a great discussion. I was kind of observing, you know, some of the slides that have the commonality right from starting from University, William, and then kind of going to Mihir and also to YZ. So any questions from the audience here, because it is an exciting topic, and I don't know how many of the folks have this threaded and concentrated curriculum view, but happy to have this panel answer those questions.
I'll just jump in quick with a question. So we're trying to move in that direction too. This is a very interesting way to motivate the students and provide some background for their studies later on, which is all grueling theory. The question I have is, how do you guys handle the issue that we have is our students don't need to declare their major until the second year, which kind of makes the freshman year difficult to specialize anything.
So I think this question is for Bill, correct?
Yes.
Whoever, yeah.
A great question. So we have, so this course that we offer has become very, very popular, and is now adopted by actually all of our departments. And so we offer a very large lecture, and then laboratories that last Thursday and Friday, accommodating all the students. There are actually many, many students that are undeclared. And what we find is that invariably students discover something in the course. So both courses inherently embrace embedded computing and computer engineering. they introduced the concept of sensors and sensing, electronic measurement, of course, and then the essentials of signal processing. Then finally, there's exposure to the design of an algorithm, and then implementation and demonstration. So it's inherently designed to inspire anyone within the ECE curriculum. But actually, to give you an idea of its breadth and its capability for undeclared majors, we get students from biomedical, civil and environmental, chemical, computer science, mechanical and aerospace engineering. And in fact, our School of Liberal Arts and Sciences wants physics students to enroll. We haven't yet been able to expand that yet, but well, let me put it this way. Our dean would like to have every student in our school every year take the course. It's really sought after. Again, it's a game changer. So I think it's actually ideal to help students make that right selection, because they get exposed to development in the full set of ECE disciplines.
All right, you're preaching to the choir. How do we buy this thing?
Actually, I can go ahead and send out links. One way would be to, even if you Google UCLA and sensor tile, it will come up, but I can also send links out.
All right, I'll find it. Thanks.
Maybe I'll go ahead and put them in the chat for everyone. And then let us know how we can help. There's a series of tutorials that are meant to be scalable so that an instructor can adopt this without going through an enormous investment of training and so on. So I now teach this course with undergraduate course mentors who are students that have taken the course and then want to participate in leadership. They learn a great deal from this. And so that actually replaces teaching assistants. They can still participate, but they're not necessarily needed. So that's a big payoff too. What we find is that students that go through this sequence of taking the course and then leading end up also being leaders in the student community and the student organizations. So I'll go ahead and put links in the chat right now. Thank you.
Thanks, Bill. I have another good question from Mihir. What are the skill sets that you require for your startup?
And that's a pretty broad question. For any startup in general, there's no skill set. You just have to do it. Like nothing will prepare you, no courses, books, that's all BS. You have to just quit your job or whatever, take the guts, take the leap like any entrepreneur and just do it. And you'll learn on the job. But for my startup in particular, there was another set because our customer was electrical engineers. I think having worked as an EE at these companies that were referenceable and our customers like Tesla's our like fourth customer, like some guys in the labs there because I knew them and it helped and things like that. So that helps. Being one of your customers or having been the demographic at some point usually helps in any sales role. But yeah, with startups, I mean, you got to just go for it. You can't like pencil it down for a year and try to get the plan. I mean, you'll probably fail. In fact, you'll probably fail regardless. So why waste your time? Just jump into it, and that way you'll fail quicker and you can move on to something else more quickly. So
I asked this question, Mihir, because I was on campus last week and there was a question about, how long should one say technical in ECE and follow business? So I had a technical role and I continued with it. I went to the business side, but I'm always technical too. So do you suggest that these classes on like entrepreneurship or kind of combining the skills that Bill was talking about, kind of leadership stuff, does that help?
Yeah, I mean, they help if they're technical in that capacity. Like if you go through venture financing and you understand how is debt kind of used and how is equity used and what's a term sheet and like that stuff is useful. Generic stuff, it'd probably be better if you just spent a year trying to do a startup. And if you don't have an idea, then yeah, I would say go as technical as you possibly can. Try to get a blue chip name on your resume. because oftentimes, even if you don't believe in that, or all the companies are saying, I mean, sorry, like the people you're working with at Tesla generally are going to be more, like, they're probably going to be smarter or more just hardcore than somebody at some random company that isn't as competitive. Like, it's competitive for a reason. So you'll learn a lot being around those people, and usually it helps when you're not the smartest person there. And then oftentimes your coworkers there will go on to do great things, like many companies like PayPal, for example. They all went on to do obviously great things.
Thank you. So YC, I have a question for you. So I loved your graph, which shows the skills or the jobs related to the regions. Can you elaborate a little bit on that? Like, how does one know what kind of core career pathway or the threaded curriculum one should take? How does one decide that in Freshmen?
That is exactly the thing that I wanted to discuss on this panel today. I feel that, okay, first of all, let's take a step back to 12th grade. How do students select the university and the major they want to focus in? And the answer is probably a very haphazard process for a big portion of the students applying to universities. And unless the family is very focused and the student knows from a very young age that he or she wants to be an engineer, otherwise, it could be a very random thing. Maybe they said, "Oh, well, I have a friend who's attending this university, and I want to be with this person." Yeah, I've seen a lot of that before. But then once they get into the university, right? I feel that it is in some ways up to the department and also the industry to show the students the possibilities of skills and knowledge they will pick up in the major they have selected, in this case, electrical engineering, where it could potentially lead them. And I don't know how much this is done on campus nowadays. I think also a lot of this has been pushed to the career centers and career services, which I believe are getting underfunded nowadays. I've talked to a lot of career services people on campus before. And so I honestly don't think students actually know where they can end up in after graduation. And so this is where, companies like DigiKey and organizations like ECE will basically come into play. I think it is important to let students know what's ahead, right? I forgot also IEEE.
Mm-hmm.
And the students have to be motivated enough to actually go find out what's out there. Go to trade shows in the area when trade shows resume, and I hope they resume soon. And read more industry newsletters and subscribe to websites like All About Circuits or EE Times. These are, things that engineering students should know, and they should have mapped out what their career is before they enter their junior year. So going back to the word cloud, that was my first stab at attempting to answer this at a way back when, in I think probably 2015, and I believe it was actually Kim Simpao from ECE who reached out to the company I was working for at that point in time, and she asked, "Can I build something for an ECE career discussion?" And I thought, okay, great, I can probably do that. So that knowledge, the information encapsulated in that slide may be a little bit obsolete by now. After all, 6 years later, the industries have changed, but I believe that a vast majority of that still holds true. Companies are still hiring embedded engineers. Companies are still hiring PCB designers. Maybe the area of focus would have changed a little bit. Maybe students will now need to know more about RF design, antenna design, or maybe things like Linux, or the ability to script in Python, or understand machine learning. And so I believe that the hot topic keywords have changed over time, but then the basic skills they must have would pretty much remain the same. And I don't think it'll ever be obsolete, because that is the bread and butter of electrical engineering. And you know, to Mihir's point, and that a very impressive list of things a student will have to know when to prepare for, at that point in time, a new college grad will have to know by the time to prepare for an interview. I think that list will remain, it absolutely hits home today, and it will remain true 10 years from now. Maybe Altium would have, maybe some of the software tools on it would have changed, but the basic knowledge is there. And, you know, it is these electrical fundamentals that a student will have to pick up very early on, and be very comfortable with having a very flexible mindset, open to learning, open to picking up technical skills very quickly, and being able to run and use the technical skills competently as early as possible. And then that's where the threaded or integrated curriculums that Sid you know, talks about kicks in, because that's when they realize, okay, you know what, I think I'm really proficient at RF engineering, and I want to get into this area. And so, in my opinion, it's a process. It's not, you know, a milestone a student has to hit along the way. It's a process that the student will have to understand. Number one, based on the major they have selected, what are their career choices? And would that be something they really want to do? And if they have committed to it, then they have to find out from their department, from their career services, from their peers, or from the industry. You know, companies like DigiKey, we have a whole bunch of articles and blog posts on all kinds of topics. You know, go through these articles, go through these blog posts, and see what sticks. And so it's ultimately very, very important for the students to self-educate.
I see we lost your voice.
Oh, am I back?
Yeah, now you're back.
Have I been talking to myself for the last
we
2
can.
minutes?
You're fine.
Okay. I thought, oh, great, I have to repeat everything again. Right. So oh, great, funny morning, fun times. Anyway, so ultimately they will have to self-educate and be self-motivated to understand where exactly they're headed, and then carefully pick the classes and the right threads in that their engineering department offers, in order to you know, fine-tune their skills for what they're looking for, or what their local industry is looking for.
Thanks, YC. I have one more question for Bill. I know we are about 3 minutes away. If nobody has any questions, I know we are at ECEDA and we want to kind of provide these resources to everybody. So Bill, I'm going to ask you, as you come from, you know, actually building these curriculums and threaded courses. My question is that if an EE department wants to launch a threaded curriculum course, how can they do it, and how to reduce the burden on instructors and even students?
It's an outstanding question. We've actually designed the courses with that in mind. What we've noticed is that many courses that involve a hands-on component, which of course is essential here, can sometimes require a great deal of investment on part of the instructor. So first of all the tools in both of the courses, the control systems and the IoT course, are open source. So for example, the computing tool is the STM32Cube IDE. Very fortunately, this is a very powerful IDE, equivalent to, you know, virtually any out there, but it runs equivalently on Windows and Mac OS. That's a game changer, because about half the students are on Windows and half on Mac OS. And if the tool supports only one, it's a nightmare. So that's good. Second, the kits are inexpensive, so a student can purchase what they need. We provide guidance on which USB cables to purchase and things of that sort. Many of the students have had no exposure to electronics before. And so this is their first experience with that. And I think this is really important because learning now, as opposed to learning in 2 years, makes all the difference. We've had many of these students obtain internships before their second year. And that's only because they've taken the course. Otherwise, they'd be really at a loss. So that's important. My vision is that an instructor can, for example, the summer before the fall curriculum, literally sit down with a graduate student, ask the graduate student to go through the tutorials that are all online, do a complete walkthrough, learn. It's straightforward, and we can help. And then offer the course. It's been effective actually at all levels. The Harvard Graduate Extension follows the course, and there are many freshman offerings. The course is even being translated into another language by another instructor overseas right now. So yeah, but let us know how we can help. The main objective is, well, not to, for example, own it or brand it or anything of that sort, but to enable it being adopted. It really is everyone's. And that's the objective. So again, I might mention it's very effective at the freshman level, but if someone wanted to offer this as more of an upper division launch, that could be done too. And I might mention again, there are two. One is control systems, where our objective is for the first time to enable control system students to have access to a hands-on design opportunity. Absent that, control system students don't have an opportunity to be exposed to a hands-on real control system. They only view it through simulation. So as we developed this, we realized this would also map into the freshman curriculum perfectly well and would be very effective because of its mechatronics aspect and its broad nature, its diversity relative to the threaded curriculum. And so that was really effective as well too. I might mention, so someone might wonder about, well, is the level of challenge too great for freshmen?
Yes.
We find that they do incredibly well. So there's a selection process midway through the course where they select a final project. And no matter how I work to develop ideas, they always exceed me. But I might mention one more interesting example. During the pandemic, well, previous to the pandemic, there was a hands-on course for high school students that could actually arrive at UCLA and be involved in effectively a tech camp, a very intense course for 3 weeks, high school students. When the pandemic hit, the only online hands-on course was this one. So I was asked to teach it twice. Never done that before, but just the pandemic and the urgency, you know, energized me, and we did this. Those students all did very well, and it was absolutely their first exposure to, for example, C code. One group of 6 students went on, did some research, and completed a project just recently. There'll be a blog out there about this very soon that definitely exceeds anything but a top senior capstone design project. These were high school students, and they completed this before entering the university. So yeah, it works. The course mentors are really useful because they can be numerous. They love the opportunity to guide other students. And because they've been successful, the other freshmen realize, well, wait, I can too. This person's only 1 quarter ahead of me, or 2 quarters. And that kind of connection is a great inspiration. And it's all low cost. There's a leading community college here in LA that's adopting this right now. And that's important for us too, because many of our transfer students haven't otherwise had this experience. So there's a big effort to get this moved out into the community college programs. But I'd love to help. Just let me know. Please contact me, and we can Zoom. I can send information via email, whatever anybody needs. Thank you.
Thank you, Bill. I think we should collect those resources and probably have a CEDA put them on their websites. I think we're running out of time, but I know this is a very interesting topic for all of us, and we could continue to talk from all different angles. And I think we did not even cover the industry involvement. And I think, besides what you're doing, Bill and Mihir, you're kind of contributing to the most practical skills that, engineers need. I'm definitely using that in my future campus visits. But I also feel like, introducing industries introducing themselves in the freshman year, especially ECE oriented companies, kind of have to do that, because otherwise you lose them and they don't really know, what direction they need to take. So I think it's this collaboration between university and industry, and also the practical skill sets that students need to learn, and how does one integrate that into curriculum is also key. So thank you again for being here. I appreciate your time and great learning, and thank you very much.